This video will explain how to correctly reason the following question. Before we begin, please remember to have a highlighter and a pencil with you, and also to pause the video or rewind the video whenever you need to review something. Ruby and Brittany are standing some distance apart on the same side of a building, 50 meters tall. There's a lot of important information right here. Ruby and Brittany are standing some distance apart. So here's Ruby, here's Brittany. Some distance apart, unknown, they labeled it with an X. On the same side of a building, 50 meters tall. That means the building is 50 meters tall, so you'll see the height of the building represented here. From where Brittany stands, the angle of elevation is 30 degrees. From where Ruby stands, the angle is 60 degrees. So remember, an angle of elevation is always going to have to be along the ground looking up. So if you look at where Brittany is, right here, this is her looking up at a 30-degree angle to the top of that building. And then if you look at Ruby, she has a 60-degree angle looking up to the top of that building. Both of them happen to be looking in the same spot, but from a different place. Okay, we have to find the distance between Ruby and Brittany to the nearest tenth of a meter. And they represented this distance by, remember, that variable x here. All right, so it's really important when you're looking at this question to understand that there's actually two right triangles formed in this problem. The first one, if you look at, is Brittany's look at the view here. And Brittany has that 30-degree angle looking up along the 50 meter, and I'm going to just label that right along the side here. Then there is another right triangle formed if you look from Ruby's perspective, where she is 60 degrees up looking along that 50-meter wall. Both of them, you can see, are forming right triangles because the height is always perpendicular with the ground in these problems. So that's why it's making that right angle there. All right? Now, we want to find x, and you can see that x is some type of horizontal distance. So it would really help us to know what the horizontal distance is for Ruby's and Brittany's perspective. So let's look at Brittany first. I wonder how long this distance is. Let's label it with a y. And now let's look at Brittany's, sorry, is this one Brittany? This one is Ruby next, sorry. And her distance we'll label a z. In order for us to find this distance here, we're going to need to take the longer distance, which was from where Brittany was standing, and minus from it the shorter distance from what Ruby is standing, and that will get us our answer. So we're going to try to find, using two different trig equations, we're going to try to find the y distance and the z distance. So let's start off with our first question. Which trig formula will I use, SO, COT, or TOA? So here is our input angle, and it looks like I'm going to have to go across from it to label my opposite side. Across from the 90-degree angle, I'm going to label my hypotenuse side, which for some reason is not letting me write it alongside it, so I'll just label it like that. Okay, and then I also have to label my adjacent side. And my adjacent side is going to be the one next to that angle, that side Z. Okay, so it looks like I have my opposite and my adjacent's the one I want to solve for. So I'm looking for something dealing with opposite and adjacent in it, which eliminates anything with a hypotenuse in it. So I'm going to be using my TOA, my tan of that input angle. So one of my formulas will be tan of that input angle equals opposite over adjacent. And now let's analyze our other triangle that we have. So let's go to the triangle for where Brittany is standing. and we're going to look at that input angle. So I'll make a little mark at the 30-degree input angle. And from here, we're going to go opposite all the way across. You'll see it's the 50 meters. The adjacent will be the one right next to it. And our hypotenuse has to be across from this 90-degree angle. So it's going to be here. And it's going to be right there. Okay, so now when I'm choosing my trig identity, I need to make sure I'm looking at my adjacent side and my opposite side. Happens to be the same case that we had before. So it's going to be another tan problem. Tan of 30 degrees is going to be my opposite over adjacent equation. Now both of them will be slightly different though, so I'm going to go back to the first one. My opposite side was 50. Tan of 60 equals 50, and my adjacent side was z. And now for this other one though, my opposite side is still going to be 50, but this time my adjacent side will be y. So those are the two equations I'm going to use. Now I have a second question I always have to ask myself. Am I solving for a side or an angle? Since I want the horizontal distance, it looks like I'm solving for a side, not an angle, which means I'm going to be using the regular tan and not the inverse tan. So for both of these equations, I want to make sure I'm using regular tan and not inverse tan. So I rewrote both equations, and now since I'm not solving for an angle, I'm using regular. I'm going to use proportion, so I'm putting it over 1 and cross multiplying. 1 times 50 is 50. Tan of 60 times z is z times tan of 60. To isolate z, I need to divide by tan of 60 on both sides so that I reduce out that tan of 60 and have z by itself. Okay, and now I'm going to need to pick up my calculator and make sure I'm in degree mode when I do this. I want to do 50 divided by tan of 60, or I can use that alpha y equals button to make a fraction. So I'm going to give you a second to type that in and then see if your answer matches mine. My calculator gave me 28.867513, but I got to remember that the original question said that this needs to be to a nearest tenth of a meter. So I'm going to have to round this 8 by looking at that 6. It will bump up the 8 to 28.9. So that is my answer for Z. Now we're going to do the same thing again because remember, we're solving for the regular side, so we're going to use proportions here, not inverses. So 1 times 50 is 50 again, but this time I'm going to do y times tan of 30. And in order to get tan of 30, in order to get y by itself, I need to divide by tan of 30 on both sides. This is where you're going to have to use your calculator. Please make sure it's in degree mode. Find out what 50 divided by tan of 30 is, or use that alpha y equals button. Again, I'm going to give you a second to plug it in and see if you can get the answer. When you type that into your calculator, you should get 86.60254070378. Keeps going, so you need to remember to round to the nearest tenth, which is why I underlined 0.6. Look next to it. It's a 0. It's going to leave it as 86.6. So remember, one of them was a distance Ruby is away from the object, the building, and the other one is the distance Brittany is away. In order to find the final answer for x, we have to do 86.6 minus 28.9, which will give us 57.7 meters, which happens to be answer number 4.